finish the last question you were on, and then we'll chat here. If you could pull out a different colored pen, that would help you with knowing where you need to study further. You need highlighters in there. Throw one to you. Raise your hand if you need something. Good at green. Anybody else? Okay. So, how do we feel in the first like half of that? Not bad. Like it's just anode, cathode, calculate the E cells and so forth. There were 3 or 2 questions on there that are like random. Aluminum currently produced and originally made. I knew you would know those, and I did not expect you to know those. That was just what was on here, and I wanted you to try anyhow. And if you've read the end of the NMSI, it actually does say it in there. So, but that's been like a month from, you know, it's been a while since you've seen that. So let's check. 1, C. Come on, we gotta go. Okay, C. Good. 2, A. Very good. 3. B. Good. B. You had to identify anode and cathode first, and you had to identify that by saying, hey, E cell has to be positive, right? Spontaneous is positive E cell. And who was the anode in that? Number 3. Magnesium, and then the other one was the cathode, so that's how you had to arrange that. 4. C. Very good. 5. E. Good. 6. D as in dog. Yes. You just have to do some math, mental math, hopefully. You weren't like calculating that for yourself. I expect you to do some subtraction. 7. A, the most reactive, or most, the best oxidizing agent is the most positive value because it's the most likely to be radiation. So on that list, it was fluorine. 8. E as in elephant, yes. Simple subtraction again, just had to identify anode and cathode first. 9 is calculation-based one because we had some crazy concentrations to plug in the Q. What do we get? What do we get? E as an elephant, yes. You had to do E naught cell minus 0.592 over 6 because there are 6 total moles of electrons transferred. We get that far? Right? Okay, so the 6 moles of electrons are from 10 losing how many, or 10 gaining how many? And number 9. 2 electrons, but then aluminum changing by 3 electrons. So 6 doesn't equal 3. 2 doesn't equal 3, so we make that quantity go up to 6 or at least come to multiple. So yeah, you divide by 6 electrons in that one, and then do log of Q, but Q setup is pretty complex. So what's Q setup? 10(2) to the 3rd times aluminum 3 plus to the 2nd over 10(4) to the 3rd, right? So that was just a Nernst equation setup. 10? 10 is what? A, good, because we have, and we had one of our cells yesterday, was this one in particular. We have a halide, the halides are priority. So before I move on from that, can you just run on the back of your paper the list of priorities for electrolytic cells? So, oops, that's not what I want. Grabbing this. All right, so you have a little list. Molten. So in molten state, who's priority at the anode? I'm not going in the same order as your table. Well, molten salts, many times they contain halides, so yeah, I'll say that. I was just going to say the anion, but yeah, you're right. Usually it is a halide in our molten salts, like sodium iodide or potassium iodide or lithium chloride, any of those. So the cathode is going to be the metal, right, which would be the cation. So many times it is a metal. So molten is easy. You use the 2 ions that are there. You make it happen. Okay. Many times they are salts, so you're right. Many times it's halides and metals. So at the anode with aqueous, what do we have? What's our priority? Okay, so this is in the order I gave you, right? Yeah. So we have halide. That's our priority. That's an halogen, right, in group 7. Keep going. Who's next priority? Water. So we only had how many options here? 2. What's the oxidation, which is at the anode, right? What's the oxidation of water? Oxygen, 4H pluses and 4 electrons. Good. You basically memorized that because I think you've written it 3 times at least. At the cathode, your priorities for reduction are what, and what. If it's acidic, you better take that H and go what? To make H2. So we have 2 H pluses, 2 electrons to make hydrogen gas. That's priority 1. And then transition metal. If we have a transition metal, it will just basically go to its solid form because we're going to take ions, give it electrons to make solid. And then lastly, water, right? And what does water produce here? It does make hydroxides because we're not in acid, we're in base. So we're making what though? Hydrogen gas and have 2 hydroxides. 2 hydroxides and what, 2 electrons? Balance now? Yeah, okay. 2 electrons. Oh, on the other side. All right, so just wanted to make sure you know your priorities because I expect that you have those memorized because those are how some questions will be phrased, like what will be produced at the anode or the cathode. That's what we're talking about here. All right, number 11. Say again. One more time. I thought I heard 1. E as an elephant, I thought I heard that. Okay, I heard a couple of other answers as well. So again, this is just aqueous. Aqueous, we're not going to be making lithium at all, because lithium is going to be explosive in aqueous solution. And bromine is definitely going to occur at the anode because it's a halide. All right, 12. A, you had to do some stoic. You started off with what? Grams, went to moles of copper, then moles of electrons, and then Faraday's constant getting coulombs, and then coulombs to seconds, right? So if you need to write down that process, you have it. 13. B again. Sorry, I don't know where I got again from. B. And we started off with what? Hours, went to seconds. You could have gone from minutes to seconds, but regardless, you had the time. Seconds to coulombs, so you use your amperes, right? 6 coulombs per second. And then moles of electrons, and then moles of silver, and then grams of silver. Okay, so that's a stoic one, which was pretty challenging mathematically. All right, the random factoid ones, 14 is D, fun fact of the day, and 15 is E, other fun fact of the day. That is on the MSI reading note, so just read over that. 16 is A, good. You just had to write it out for yourself and then match it up to the answer. So bromate goes to bromine, then you have 3 waters on one side and balance out your charges. 17. No. E. 17 is E. You use the reaction you had in 16, and then you write out N2H4. What does that have reaction for N2H4? Oh, sorry. N2H4 goes to nitrogen gas, because you could see that from the reaction given. You had to match those up. But then you needed 4 hydrogen ions to match with the 4 H's and 4 electrons. So since this one had 4 electrons and the bromate one previously had how many electrons? If you got 16 wrong, you probably got 17 wrong, let's be honest, because you needed it. But in the end, you can now balance this. This goes to bromine, ion, 3 waters, 6 H pluses, and what else? Where's my electrons? Where are they? They're in the reactants, but how many do I have? 6, because this is 1 minus, this is 1 minus. This 6 H plus needs to be canceled with 6 electrons. So what's the common factor between these? 12, right? Because I can multiply this one by 3 and get to 12, and I can multiply this one by 2 to get to 12, which is how you end up getting 3s and 2s across the board for those coefficients. 18. D as in dog. Okay. Everything else, I think, is easy enough to see its redox because you're taking ions and making solids or gases. You're taking gases and solids, you're making compounds. So that means they're changing their ionic states, which is their oxidation states. All right, so count how many you got out of 18, and then give yourself some cushion because 14 and 15 were kind of bogus questions, just to see where you are. Okay, and then now I want you to start FRQ 2013. Okay, so go to the back of your FRQ packet. Hopefully you still have those out and available. And I'll just give you a couple of tips just to look over for the weekend. The latter FRQs, like later years, are very similar to what you would see on your end of year, your AP exam, and like you would see on your exam. Taz and Marcus, just hold on one second, okay? And you guys can finish. So I definitely want you to do 2013 and 2011. Those are the last two FRQs in the 12 FRQ packet there. The rest of them that are there, if you wish, you can do those for study evidence. I think you've had enough FRQ practice at this point. Monday specifically, I'm checking on the board to kind of review with you 2013 and 2011, because I feel like they bring in a lot of cross-curricular, kind of bring in some thermo and some kinetics is another one, equilibrium, and even one of the last questions deals with like environmental chemistry, which is why I wanted to do an environmental application today, but we're not going to have time. We can try that on Monday though. So this is something we can try to do Monday. Otherwise, work for the last little bit on 2013, all right? And there's more candy.
Wow.
Guys, use your time. 2013, let's go.
But you know, she's always
They are I hit them under there's no way the sublimation work. All right, thank you. Jake, why are you doing
Oh no, I was looking at
Guys, that one, I had it pulled up. So that one's a little bit on the blurry side. Here's what the values say. Sorry, I have 2 minutes with you. Can you see that? Yeah, okay. So it says 235 grams of aluminum. Can you actually take pictures of that working? You can also just Google AP Chemistry 2013 FRQ or pre-response. Don't look at the answers. Look at the question, and you can see it. But let me tell you the numbers. I know you already know. I'm telling you this with no confidence that you actually didn't know that. All right, so 235, and then it says 152 amps. Calculate the volume of CO2 at 301 Kelvin, 0.952 atmospheres. You can jot those things down. I'm going to scroll down in a second. This document. All right, my to-do list. If you're going to do this in second period, though, you know. All right, peace out. Bye. 2013 every Monday. That's an easy class. They're having a sub. Do you recommend it?
Yeah, I have.
Okay, sweet.
So when you sign up for your classes, you might have to like
Yeah.
So you'll just have to
Yeah, that's pretty cool. That's pretty cool.
We've not gotten here on
Yeah, he's amazing on the study, right? I tried that, so he's like the best kid in the school.
Yeah.
Amazing, we still have it. All right, cool.
Yeah, I gotta. My mom's actually in Florida right now, so hopefully she'll do it.
Okay.